Hi everyone, welcome to the day 5 of Learning Data Science in 100 Days. Before starting today's session, so you need to go through the introduction that was given on day 4, where I have explained the difference between a list, a tuple, a set, as well as the dictionary. So it would be recommended that before going through this tutorial video, if you haven't seen the day 4 video, at least have a quick look into the introduction part, so you get the clear understanding about all these different data types. So today we are going to see sets as well as dictionaries, so you will get a sense of understanding like how they are different from each other and why they exist in Python. So now going into the data type sets as well as dictionary, as you can see on my screen, the sets are much more faster than list. So the sets as well as tuple are like equally faster, like definitely much faster than list. And the advantage of set is it allows operations such as union as well as interset. So if we have, let's say, two data set, we would want to do a lot of comparison between them. We want to identify what's common between them, or what is existing in one list of items whereas not present in the other. So if we are going to do a lot of those kinds of operation, then it is recommended to define them as a set and perform those operations. And the other one is that set is not ordered, like we don't have any indexing, so which means that you can't have any duplicate values, unlike a list or a tuple, which allowed a duplicate value, because we have indexing. So even though if there is like multiple values, like same values coming up multiple times, their individual position or index would be different, whereas since this is unordered, we can't have any duplicate values. And one thing about set is it can't accept any element which is mutable, like such as a list or a dictionary. And dictionary is a key value pair, so we will be going through dictionary as well, like how to access dictionary using the keys. So this is also unordered. We don't have any index, whereas we use key to access them. So now going into the set, so what we are going to do is we are going to define the set using the curly brackets. So list, like the input needs to be within the square brackets, whereas in tuple it needs to be the normal brackets. In set it needs to be curly brackets. So as we go into our example, so this is an example, like a set underscore companies is a variable to which we pass these values. So what I'm going to do is I'm just going to pass the values into a variable, print it, and then we are going to print the data type and see what is their data type. So as I execute this, so if you see here, we are able to print the list of values. So here, since it is within the curly brackets, we can see that it's been defined as a set. So now we know how to pass, how to define set, and how to get get some values to it. So what we are going to do is we are going to see some of the operations that can be performed on a set. So unlike tuple, which is immutable, set is similar to list in terms of it allows us to add or remove values to it. But of course, we will see how it is different from list. So now going on to the next one. So what we are going to do is we are going to add an element to it. So in order to add an element to a set, what we are going to do is we are going to use .add function. So set.companies is the set to which we are going to make the changes. So what we are going to do is we are going to use .add, and we are going to pass the element that needs to be added to the set. So let's add Microsoft and then see what happens. So as you see here, a set is not sequenced, or it's not ordered. There is no indexing to it. So if you see here, like once we added the element Microsoft, it's not added towards the end. By default, what happens is in a list or a tuple, when like in a tuple we can't do any changes, whereas in a list, when we try to add an element, it gets added to as a last element. Whereas when we use insert, we can insert it, of course, in the middle of the list too. But by default, when we add something, like it adds as a last element to the list. Whereas here in this case, since it is unordered, when we add something, it gets added, but we can't be sure about its location. So whatever the location is, it doesn't matter, because like there isn't any indexing or sequencing. So that's how we add an element to an set. So now moving on to the next one, let's try to add the same element again and then see what happens. So we told that there is duplicates are not allowed. So when I try to run this one, so what's happening is it is not throwing any error, but what you see is, you see this set is unchanged. We are trying to add an element which is already existing in the list, in the set, so it's not being changed. It doesn't throw any error, and it just remains the same. And now let's see how, let's see what happens when we try to add an integer to a set. So as you see, when I try to add an integer, it gets added. There isn't any error. So similar to maybe like a list on the tuple, set is also can have multiple data types as an element. So here we can see it has a string as well as it has an integer as an element. So what it can do is it can also have an tuple as an element. So when I am trying to add a tuple with the values 1, 2, 3 and 4, and then let's see what happens to the set. So as you see here, when I try to add a tuple, it gets added, and it has become a part of the set now. So it includes string, a tuple, an integer. So it can hold, it is heterogeneous, it can have multiple elements with different data types. So that's something that is very different in Python, unlike other languages where generally they are homogeneous. So now let me try to add an array add a list and then see what happens. So now what I'm doing is I'm just using the same set. I'm using this the same and function, and what I'm doing is I'm trying to add an list now. So when I try to do this one, so we get an error. So as we saw in the top, so what we can do is it can't accept, a set can't accept an element which is mutable. For example, list as well as dictionary is mutable, which means that mutable means changeable. So an set can have multiple data types, but it can't have an list or an dictionary as an element in it. So that's something that is different for a set. So now we have seen how to add different elements and what cannot be added to a set. So now what we are going to do is we are going to see how to remove an element, what kind of functions can be used for it. So the first one is called as discard. So if you see here, what I am trying to do is I am trying to discard an element called a Tesla, which is actually not in the set. So let's see what happens. So when I try to execute this one, so as you see, it doesn't throw up any error. The element doesn't exist, but when we try to remove something that is not present in the set, it doesn't throw up any error. There is another operation called as remove, which is also used for removing an element. Let me use this one and then see what happens. So now when I try to remove an element which is not present, so when I use remove function, what happens is it throws up an error. Whereas when I use discard function, it doesn't throw up any error. If this particular element is present in the set, it would have been removed. If it is not present, it doesn't matter. It doesn't throw up any error. It doesn't stop there. So that's the difference between discard and remove. So what I'm going to do is I'm going to remove, let's say 1 to 1. So now let's print set companies and then see what's happening. So if you see here, now after using discard 1 to 1, we can see clearly that element 1 to 1, which was present earlier here, is now removed. So the difference between discard and remove is when you use discard, when you are not sure about the presence of an element in an set, so maybe we can make use of discard. So what happens is, if it at all it is present, it would be removed. Whereas if it is not present, it doesn't matter, it doesn't throw up any error. Whereas remove can be used when we are sure about the presence of an element, and when we want to remove it, we can make use of remove function. So that's how you can delete an element from a set. So now we can try and see the other options, like what we used to do in an list. So what we are trying to do is, we are trying to delete an element based on the position. So in case of list, it used to work because like a list is indexed, which is ordered. So there is a position, like there is an indexed position number 4. Whereas now when I try to remove it, let's see what happens. So as you see here, set doesn't allow deletion of an indexed item because like set is not indexed, like as I said. So we can't do it. So if I just use delete of the name of the set itself would be deleted, but we can't delete based on the position, because there is no fixed position for an element in a set. So next one is pop. So let me pass an position and then see how to delete using the pop function. So when I execute this, same thing, like I can't delete based on the position because there is no fixed position in a set. So what I'm going to do is, I'm just going to remove this one, and then let's see what's happening. So now when I execute it, so as you see here, it deletes an element. But what happens is, so usually in a list, when we use the pop function and we don't pass any location or index, by default it deletes the last element of the list. Whereas in case of an set, what happens is, it deletes an random element. So if you see here, so this was the original set. So after using pop, what has happened is, it has deleted the first element. So it's completely random, like it can pick up any value and delete it. So that's the difference. So usually, so we don't use pop because it randomly deletes in a set. So we usually delete by passing the value that needs to be deleted. So we can make use of discard or remove in order to delete a particular element. And so now we have seen like how to add element, how to remove element in a set. So next one, we are going to see how to combine the different sets, and then see how some of the operations such as union and interset that can be specifically performed on a set, which can be usually done on the other data types. So now what I'm going to do is, I'm going to define two sets, like tom1 underscore set as well as tom2 underscore set. I am passing a value to each one of them. So the values that is present in tom1 underscore set is different from the values that is present in tom2 underscore set. So when I use union, we are going to see what's going to happen. So I have created a third set, calling it as tom3 underscore set, and combining the top two, and then let's see what's happening. So as you see here, the union operation, very similar. Like if you are familiar with an SQL, like union would mean that it would adds up the values from the two tables that we pass through. So here in this case, we are passing two set, and then we use the union. What happens is, the values, the elements present in those sets are combined to form an third set. So here you can clearly see this as well as this is added up and formed as tom3 underscore set. So that's how we combine. So we have seen like how we usually combine in a list. So in a list, in order to combine, we use plus operator, and we can use, like, we can combine any number of list using a plus operator, which acts as an append function. So here we need to use union in order to combine different sets. So now let's see how to update and set. So what we can do is, we can make use of update. So now what I'm doing is, I'm creating an set with a value Tesla as well as Zoom as element. What I'm doing is, I'm updating the tom set 3, which is the set that is present here, with the new values. Let's see what happens now. So as you see here, what's happening is, whatever values is present in tom4 underscore set, if they are not present in tom3 underscore set, what happens is, they would be added to it. So now let's see, I'm going to add something. that is already present. Or this one, let's say it's already present in tom3 underscore set. So tom3 underscore set already has Amazon. So I'm going to try to add an element which is already present. Let's see what happens. So when I run this, you can see that we are getting the exactly same result. So which again proves us that a set can't have any values that is a duplicate. So if the value is already present, it doesn't do anything to it. The update function looks for the values in this data set, and whenever the tom4 underscore set has any value that is not already present, it gets updated into this particular set. So now let's see how difference function works. So similarly, like I'm creating two sets here, passing some values, some default values, and then we are going to see how to get the difference between them. So when I execute this one, so what you can see is the tom set 1 minus tom set 2 is being performed, which means that whatever is there in the tom set 1, that would be the original value. If there is any value that is present here occurs in the tom set 2, those values, those common values will be deleted. So this means this can be seen like an intersection. So whenever there is something that is common between them, when we use the difference, so that is being removed. So if you see here, these two set has a common element called apple. So when I do tom1 underscore set minus tom2 underscore set, or tom1 underscore set dot of difference tom2 underscore set, so what happens is the common element present here is removed, and the values that is present here would be displayed, the remaining values. So that's why we see that the original set is Apple and Facebook and Tesla, contains these three values as an element. So the common one, which is Apple, is being removed, and hence it prints Tesla as well as Facebook. So again, since set is not ordered, you can see that that location is not exactly same. So yeah, so now the same thing, what we are going to do is we are going to directly use the minus function. So let's see what happens now. So if you see here, so this minus operation performs exactly same as the difference. So these are like different ways of doing it. So this is something that can be done only on this set, like an union or intersection or finding the difference. So these kind of things can be done only on a set. So when we have an use cases where we want to understand the difference between two sets, so or two list of values, it is important to define them as a set and do those operations. And the third one is we find the difference and update the original value. So here what's happening is we are finding the difference between tom1 underscore set and tom2 underscore set, but since we use difference update, what happens is the tom1 underscore set is updated based on the difference operation that we are performing. So these are all some of the operations. So now what we are going to do is we are going to pass three sets, tom1 underscore set, tom2 underscore set, and tom3 underscore set, and we are going to see whether there is any common element between them or not using is disjoint. So the first one, what I'm going to do is I'm seeing whether there is any common element between tom1 underscore set and tom2 underscore set. So is disjoint is used to check whether there is whether there is nothing that is common, whether it is being disjointed, which means that whether they are disconnected, not connected with each other. So when I execute this one, the result should be false. Like as you see, like the result is false because there is a common element between both of them. So the common element is Apple. Whereas when I try to execute the second line, what happens is when I execute this, it returns true because between tom3 underscore set as well as tom1 underscore set, there is no item that is common. The various elements that is present here as well as here are completely different, which means that they are not overlapping. So it is being disjointed. So that's how it returns true. So these are all some of the operations. So as you see here, like you can, like you would have understand like why set is different, like why set is existing for in the first place when we already have list as well as a tuple. So set is generally used for this kind of operation when we want to understand difference between two list of values, like based on the values to see if there is anything common, whether there is nothing common, whether to find the difference between them. So when we are going to do these kind of operations, it is best to use is to define them as a set and use it. So that's it about set. So now we are going to see about a dictionary variable. So dictionary is nothing but a key value. So there is no indexing, it's not ordered. So whatever value we pass, it needs to be passed to an key. For example, here in this case, so similar to set, this is also we use the curly brackets for defining a dictionary, whereas the one difference is each and every value. So this is the value and here this is the key. So each and every value needs to be assigned to a key, and we can fetch the values by using the key. So when I run this one, so you can see later this is how the element of an dictionary would be. So it holds the key as well as the value. It holds the key and the value. So here a dictionary can hold like a string, an integer, or it can hold a list or a tuple or a set. Like it can hold whatever value that we can pass through. The only thing is it needs to be accessed by using the key. So now what I'm doing is I'm going to see how to access the elements of a dictionary. So we can access, as I said, using the key. So when I run this one, so as you see here, I am printing the value of the key name. On second, I'm using the key here in order to print this value. So that's how we access the various values. We use like this. Dictionary doesn't have an index, whereas it has something equivalent called key, which we use to access the various elements. And of course, like very similar to list, we can do changes, which means that a dictionary is mutable. It can change. We can add elements to it. We can delete elements from it. So here, what we do is we are not using any function like kind of add. So we use this is the dictionary. We create a new key and we pass the values to it. So once we just like that, doing this one, what happens is this is added as a new key that we can see here as a last element, and these values are added as the value for the new key. So that's how we add a new element to a dictionary. Second one is after adding, let's say we want to delete it. Of course, we can use something called as a pop item. So similar to list, what happens is this pop item deletes the last element that we added. So executing this one, you can see that the last element was with the key founder. So that is being deleted now. We can also delete based on the key. So here what I'm doing is I'm going to use the delete function. I'm passing on the dictionary data as well as I'm passing the key that needs to be deleted. So we want year to be deleted. So when I run this one, you can see this is being deleted. Similar to like what we saw in list, like a copy function is really important, because what copy does is it's not we are not going to create a variable that is pointing to the original value, whereas copy creates a copy of it, and any changes to the original value doesn't reflect on the copy. So as I execute this one, like apple underscore dictionary 1 has all these values. So I'm going to pass those values directly to dictionary 2 using the equal to function. So what happens here is this was explained in day 4 when we were explaining the concepts of list. So similarly here as well in a dictionary, when we use equal to, what happens is the value is not copied. So this apple underscore dictionary 2, it's just a pointer that points to the original value, which is nothing but this one. So if we do any changes to this original dictionary, it will automatically get reflected here. Whereas when we use copy, what happens is a copy of it is being created and it's been stored separately in the disk. So these are not dependent on the original value, which is here. So as you see here, what I'm doing is we are going to create a copy, as well as we are going to use eTwill2, and then see what happens to apple underscore dic2 as well as dic3 when we make changes to the original data dictionary. So now when I execute this one, so as you see here, after since I'm using assignment like eTwill2 operator here, the changes that we made here to the apple underscore dictionary 1 is reflecting here when we print the apple underscore dictionary 2, whereas it is not reflecting here because since we have used the copy function, a snapshot at this point in time is created, and any changes after this point in time doesn't reflect here. So that's the copy use of copy function here in dictionary as well. And clearing and deleting the values of dictionary. So the clear function would clear the values, whereas the dictionary is not deleted. So when I run this one, we can see that it's printing as none, and whereas here what happens is when I use the delete function, the dictionary itself is deleted. So when I try to print, it says that there is nothing that has been defined as such. So that's the difference between clear and delete. So now we have seen the various data types: list, tuple, set, and dictionary. And I hope you would have understand the differences between them, like why we have those 4 collection data types present in Python. Why not just one of them? So each one of them has something special in them, which is the reason for their existence in Python. So now we have a few workout examples. So these are all few examples that maybe you need to try in order to get more familiarized with all these data types. So these are all the things that will be commonly used when we work on a data science project. So we would have various elements, maybe we have to pass them as a list or a tuple, and these are all some of the operations that would be required to be performed on a real data. So these basic concepts are really important. So it would be recommended that if you practice these workout examples as well as whatever we have learned, if you can re-execute them and then understand each and every step, like how to add, how to remove, or how to combine different dictionaries, like for or whatever it is, whatever we have seen so far, it's good to practice them and become more comfortable on all those data types. So that's it for day 5. I hope you learned something new. So if you have learned something new, please give a thumbs up and subscribe. And if you think this video will be helpful for someone who's trying to learn data science or who's struggling to learn data science, please share it with them. Also, if you have any feedback, please let me know so that I can incorporate those feedbacks in the coming sessions. Thank you. See you on day 6. Bye guys.